If we talk about the IoT devices, let's start from the very end. IoT devices, each IoT device is going to send data at some fixed interval. In some cases, maybe 10 seconds, 5 seconds. Initially, when I was doing the embedded development back in 2018, 17, I didn't knew this thing, that your frequency of each IoT device can be dynamic. So that was a person, like, you have to, like, again, if you talk about the IoT device, any use case, smart bulbs, smart sockets, temperature sensors, then you have to find a balance between regular intervals and then some event-based scenarios. For example, if the temperature has, there is a change of, let's say 1 degree, 2 degree, whatever is your threshold, then you are going to send the packet. As you are not
be smart about when you are going to consume the resources.
So that evolution I have seen because the trends have been changed. Now we are seeing low-powered IoT devices. Initially, when we started, we were giving a backup of 2 to 3 days, but now we are working with the sensors, easy 3 to 5 years and up to 10 years of battery life. And they are sending data over the BLE, that is a Bluetooth efficient, low-powered Bluetooth. So then you have to be very smart with the frequency of your IoT device with respect to the use case. And so that is one thing. If let's say if you have 1,000 devices sending data around 10 seconds per day, but I was seeing maybe yesterday I was seeing the stats of one of the customer. Daily 1.8 million messages per day. That yes.
How many number of devices are there?
It was around 1,600 devices.
Okay, 1,600 devices. Each device is sending some data, but in total it's 1.8 million per day.
1.8 million messages per day.
And that message, to clarify here, is that one message. What is the size of that message?
It's around 500 bytes.
If you can tell in terms of gigabytes or terabytes, how much is there?
I've seen around that thing, transactions per second. I'm not recalling it correctly, but I was testing around 50 transactions per second. I've seen this thing. So 50 transactions per second. It when all the devices are being moving, all the users are being accessed in the system. So that was the initial stats. Now the things have, the product has matured, it has been deployed into the multiple regions, so the transactions per second have been increased. I may not recall the exact transaction per second, but from the infrastructure point of view, there are a few things. One is the scalability of your infrastructure, and second thing is there should be no single point of failure. Okay, so single point of failure means, for example, if you have virtual machine that is receiving the data of all your IoT devices, there must be a mechanism in which if the CPU consumption, memory consumption is increasing beyond 70%, it should automatically scale up. So there are two kind of scaling. One is the horizontal scaling. Horizontal scaling mean that I'm expanding this cup. Okay, this thing I'm basically it is vertical scaling up. Same thing, I'm just scaling from 8 GB of RAM to, let's say, 16 GB of RAM, then 64 GB of RAM.
That we do with our personal laptop.
Exactly. When your laptop, you feel that it is getting overloaded, so then you simply you do a vertical scale up. Okay?
Yeah. Okay.
Then there is another kind of a scalability that you called as horizontal scaling. Okay. You have one cup here, one virtual machine here. You just have one other replica of this. Then you have another replica of this. Let's say if you have 1,000 customer, there is one VM. There shouldn't be one VM, let's say 2 VMs, because there shouldn't be one single point of failure. If this VM is going down...
Is it the same thing as load balancing?
Same thing, yeah. There should be a mechanism to avoid single point of failure. And then there are your load balancers. They will help you to distribute your load. Again, now things are changing. Distributed computing. Again, the systems which we are seeing, even the TikTok, even the YouTube, these are distributed computings. These are the distributed systems which we are seeing.
So I'm trying to understand this load balancing or the horizontal scaling thing. So you have a virtual machine, or to make it simple, you have a computer, you have a server, and it's one instance with some CPU capabilities, with some RAM, and you are running your operations on it. Now, if you want to scale, one way is to add the additional resources in the same machine. Like I can increase the RAM, I can increase the disk space. That's one thing. But the other way is to add another machine, right? Which is kind of a horizontal scaling, or
we have to understand there will be different applications. Okay, if we say we are going for a vertical scale up, like if we are upscaling the same server, okay, or same laptop, just like in your laptop, you have given a good example. There is always going to be a additional cost, and it's always going to be there. From 16 GB of RAM to 64 GB of RAM, you have to spend that amount. If we talk about the horizontal scale up, then that's the beauty of scalability, the beauty of the load balancers. You can set auto rules. If I'm getting 100 transactions, or let's say 100,000 transactions per second, you benchmark your system, and then you set up those auto scaling rules that for this much load, if the CPU consumption is beyond 70%, add up one more node. If again beyond 70%, then
what you said, the vertical scaling, you are adding one more RAM to your computer to vertical scale it. But what you have said is that in case of horizontal scaling, this is one computer, one processor, you have added another one. So you have two nodes or two processors running your system. It's balanced across, two systems. But still, in terms of costing, I have paid some money to add this another machine. Why not add more RAM or more CPU to this machine?
See, now there is a different perspective of the costing. Okay, you have highlighted a good point, but we have to understand one thing, that the infrastructure we are talking about is a cloud-based infrastructure. Then that's the main benefit of going from on-prem to cloud. You are only paying for what you are using. Okay. If I am scaling infrastructure vertically, if I'm adding more RAM on one server, it's always going to be there. If I have to add multiple nodes, I'm only going to pay for that 1 hour, 2 hours, 3 hours. So eventually, if I look at the billing at the end of the month, I'm just paying a very minute amount, few dollars.
If I get this right, I'm using my machine here and it starts hanging because I'm putting too much load on it. I can have another machine here which can, somehow smartly start taking the load as well. But let's say my workload is getting down, so this machine I can put it aside or give it back to whoever borrowed it, and again start using this. So I will only pay for this machine the time I need it for.
Exactly. Okay. That's the beauty of it. And if we now talk about some production environments, because as of now we were just discussing some scenarios. In the production environment, you set a base limit. Okay, for one kind of replication, you will need at least 3 or 5 instances of the virtual, of that server, of that virtual machine. Okay, that is your baseline. If there is more load beyond that you have to pay, and the bare minimum, let's say 3 servers, you can reserve for 1 year and 3 years. If you reserve for 3 years, you get a 62% discount. So eventually you have.
So that's how the cloud server providers are.
Exactly.